I'm David. I'm the supervising editor for NPR Visuals. We're a team of photographers, designers, developers who support newsroom content. So we're tech people, but our bosses are editors. So this is my contact information. This is my team's contact information, and this is the URL for these slides. And we're going to be talking about scrapers today, the fascinating topic of scrapers. And so, do I want presenter view? Oh my gosh. No, that's not what I want.
You want the speaker notes?
Yeah.
Click on that again.
Yeah.
And then tap at the right, speaker notes. Top right.
Top right?
Is that a little to the left? Yeah.
Oh, there we go. Okay, cool. Whatever.
Are you not seeing it on your screen?
Yeah, I'm not seeing it on my screen. It's fine.
Mirror in your display.
Yeah.
Display and then drag it over to the left.
Yeah, so go make it small. And then wherever your display is for system preferences.
Usually I just have a printout.
Arrangement.
And the arrangement and not mirror displays. There we go.
So basically you have to...
Right. Presenter view.
Yeah, you have to drag that over.
Yeah.
And then click. Attempt to scroll down.
Oh, there we go. Cool. Okay. There we go. Okay, so real quick, trigger warning. We're going to talk about guns. We're going to talk about mass shootings. I work in a newsroom. We talk about the dark stuff. Also, I will probably cuss. So, you know, if you're uncomfortable with that, this is your chance to take off. And I'll try not to cuss, but I probably will. So, you know, this talk isn't actually... So we're going to talk about a story I did for NPR, and it's about the availability of guns in the U.S. and the way that we sort of got at answering some questions about the availability of guns, and specifically on the unregulated private market, is by scraping a site called armslist.com. But this talk and the story that we're going to talk about really isn't whether guns are good or bad, whether or not armslist.com is good or bad. It's really just a chance to sort of answer a specific question that we have about the world. So I just want you to keep that in mind, that that's very much kind of the journalist philosophy, right? So we're going to be technical today, and what I want to sort of emphasize, though, is not so much the technology, but thinking like a data journalist. I kind of hate getting technical. I'm kind of trying to do my part to liberate us from the iron cages of technologies that we've created for ourselves. And I have a small budget and tight deadlines. I can't afford to screw around on technical stuff for its own sake. If a scraper can help me tell a story, then I'm in. But if a scraper is really cool, but it doesn't tell me anything, it's not worth doing. And this sort of thinking is sort of the hallmark of data journalism, right? So a lot of you probably aren't journalists, but I feel like the skills that I have to use every day are actually really broadly applicable. I have a sister who's in the medical field. She's got an MBA. She does business management. And we were talking a while ago, and she was like, wow, I could really use somebody who could normalize and join some data from a bunch of legacy systems, who could summarize that data, and then who could visualize it and find some like stories in that data that I can understand what's happening in my business operation better. And I was like, sounds like you need a data journalist. So I think that these skills are in fact really broadly applicable, and that what we're doing has something to say to kind of the wider world of data. So let me tell you about this story I worked on. So I did this with a journalist named Tasneem Raja, and then my team members, Juan, Brittany, and Allison. And it's about the availability of guns in the unregulated private market. We did this in response to the mass shooting in Orlando, where it seemed that the shooter may have indeed purchased the gun on one of these online marketplaces. But we were also just curious, like, how hard is it in Orlando to like get an AR-15 on a tight timeline? And so Tasneem had been a journalist, and Mother Jones had covered mass shootings extensively, has sort of built up kind of one of the key databases in the country about that phenomena, because there's no official tracking of that. So it's sort of left to independent actors to track that. And I was interested in sort of the mechanics of getting a gun online. Like, if I want to get a gun around Orlando, like, what does that mean? And so I was digging around, and I found this site, armslist.com, and, was seeing these listings that were really interesting. So I thought maybe this could be something that we can scrape. And so I'm going to talk a little bit about the thought process that went into deciding it was something that we could scrape, and then we'll talk a little bit about the actual architecture, the cloud architecture we use, the way we organize our code, and all that good stuff. And again, this isn't about armslist.com per se. It's more about this sort of general question, and we use the scraper to help us answer it, or at least find some preliminary answers. So this is part of the piece. This is a map of the United States, and the bubbles represent the number of listings on armslist.com in the period that we looked. And there's some interesting stuff in here. We don't go deeply into it in the piece because we didn't want to speculate, but one thing that you'll see there is Reno, Nevada, which isn't labeled, unfortunately, but Reno, Nevada is a tiny city. It's 225,000 people, and yet there's a big bubble on Reno, Nevada, and, it's sort of funny. It's like, well, you've got this small city, but it's next to a state with restrictive gun control laws, and you can sort of see the ironies of the current state-by-state system right there on that border. And you see some other interesting things in the geographic view, too. So check out Oklahoma City. Oklahoma City is not a big city. Clearly, there's a lot of guns being sold, at least on armslist.com there. But Oklahoma City is at the intersection of Interstate 35 and Interstate 44, which are two of the most important drug routes in the United States. It's also two of the most important routes for your iPhones, for potatoes. These are major transit arteries, and so it's actually no surprise in some ways that a place that is heavily trafficked for all kinds of things would also be a place where guns are being bought and sold more in a disproportionate amount to the population. And so I'm kind of interested in that question. That's something that we'd like to follow up on. And you see it again when you look at the number of listings by state. And you'll see that Ohio, North Carolina, Oklahoma, and Florida are the top four. And it's probably no surprise, but Ohio is one of the most trafficked states relative to the population of the state in the country. And very gun-happy states like Wyoming and Montana are actually represented very low on here in absolute numbers, but even when we were doing the analysis, even in population-adjusted numbers. Even though they are states with lots of guns, there are not a lot of people in those states necessarily selling or trading guns on the private market. So we found some interesting stuff with this scraper. So this is a quote that ends the piece. Much has been made of the fact that Orlando shooter Omar Mateen, who purchased both of the weapons he used in his deadly rampage legally, was twice investigated by the FBI for suspected terrorist ties. But he didn't end up on the terrorist watch list. Even if he had, Mateen still could have legally purchased his guns. Terrorism suspects are not prohibited from owning firearms. Now, some typically on the opposite side of gun control debate are pushing to change that. But even if Mateen were on the watch list, and even if known terrorists were barred from purchasing weapons from licensed dealers. Unregulated private sales made easier through online marketplaces like Armslist still couldn't have enabled him to buy the weapons. So this is really sort of the central thesis of our piece. All right, so let's talk about planning to scrape. Now that we've talked a little bit about the background of the story. And this is I think kind of a really key point. So people get excited, right? Let's make a scraper. It's a popular first programming exercise. It's a popular first data journalism exercise. It seems like a cool sort of simple thing to do. But I want you to ask yourself, do I need a scraper? They're awesome if you use them right. They're really, really powerful. But you need to know what they're good for and what it takes to do them right. Because they're not so simple, it turns out. So the first thing, so the thing to know about scrapers really is that if you need a scraper, you have a data problem. So something's not right in the world. There's a database out there somewhere that's powering a website, right? But you don't have access to the database. You only have access to the website. Now, if you're working in sort of journalism or with government, that means that like somebody's dropping the ball in terms of being able to provide public data. Because if it's on a public website, the underlying structured data probably should also be public. Or if it's in your company, it means that, you know, whatever, like the old guys down in the basement, like, you know, just aren't going to get with the times, and you're going to have to deal with some crappy old legacy database, right? You know, the good data. So a scraper means you have a data problem, but like the good data, you know, the good data, if it wasn't the good data, it wouldn't be hard to get. The good stuff's a lot of times hard to get. And so that's why scrapers are often worth it. You know, data problems are a fact of life, and oftentimes for totally understandable reasons. So I actually had to scrape my own organization's website to figure out where stories were being placed on the homepage on a minute-by-minute basis, because that history isn't stored in the content management system. But that totally makes sense, because when they built the content management system 8 years ago, well, I mean, you maybe wouldn't even do it today. It's just a lot of data to keep around for not necessarily a lot of gain, until somebody decides they want it, and now it's like, oh my gosh, what do we do? So I've often, a lot of the scraping that I've done is often of some internal resource, whether it was when I was working at Fermilab, a national science lab, and we had to scrape sites because we didn't want to FOIA other departments, because that's how we got data from other departments. So we just would scrape stuff. I've had to scrape vendor websites when I worked at the Chicago Tribune, because we didn't have access to an API or an underlying data source. A lot of the scraping I've done has never actually been seen by the public. It's for internal use. And a lot of times you don't get good data out of it. So we'll talk about that in a second, but here's a couple things that you need to do. And I say this, just listen, because I say this as somebody who's made like every one of these mistakes. Don't scrape unless there's no other way of liberating the data. Like, make a phone call first, like, hey, can I have your data? It helps. Budget appropriately. Scrapers are not free. They may not cost a lot. They may seem simple on the surface, but we are talking about things that are like all edge cases. They're pure edge cases, and there's things you can do to make that easier, which is what we'll talk about in a minute. But ultimately, like, they're a pain to test. There's always going to be little things that you don't anticipate when you scrape 80,000 URLs and you've only looked at 20 or even 100 of them manually. You should consider the ethical ramifications of scraping. So one scraper project I did was concerning Cook County Jail. So they had an inmate locator, and so we scraped data about how long people stayed, what charges they were coming in on, race. We even had height and weight and date of birth, which we turned into age. so that we wouldn't have too much identifying information in this little API we created out of it. And it was funny because other departments in the city of Chicago used our data to make sure that the sheriff's department wasn't giving them bad numbers every month. Which was interesting. But one thing that was really, like, I regret is that we took down the site. We built a little too high-powered of a scraper. We ran too many parallel scrapes at once. We were not the only people doing it. It turned out that there was a bigger problem with these, like, background check sites that were scraping jail inmate data. And that screwed up, right? Because jail is not where you go when you're convicted. Jail is where you go before you get convicted. And innocent until proven guilty and all that stuff, right? So these background checks websites were pulling up jail data without actually any knowledge of whether or not the person was in fact convicted of the crime of which they were charged. In all events, we brought that on this website. Doesn't seem like a big deal. Like, well, the government, couldn't keep their shit up, right? But this is what public defenders use to know how to get in touch with their clients. This is what people use to be able to visit their cousin or their brother or their aunt or their uncle while they're stuck in a jail that people stay in often for 6-9 months a year. So you have to consider the ethical ramifications. Don't take people's stuff offline. And we'll talk a little bit about how you can deal with that. The happy end of that story is that we worked with the sheriff's department. They blocked the other scrapers and allowed ours to continue. You need to read the terms of service of the site you're reading, and you need to do your legal research. And if you're doing this for a company or even in an independent project, you should talk to a lawyer. If you're doing this for a publication or for a company, you absolutely need to talk to counsel. I think it's not optional. I think if you're doing it independently, you just need to be really careful. The key thing to look for in the terms of service is a prohibition against digital copying. So while you cannot copyright a fact, and CNN.com, for example, is full of tables of facts that reasonably you could scrape, their terms of service prohibits digital copying. And so that means that scraping CNN.com is, in fact, a legal gray area, if not illegal. So you want to be careful about stuff like that. And then you want to ask yourself, can you scrape? You want to be sort of a console and curl detective, and we'll talk about that in a second, but you want to look, what is the URL structure? What is the DOM structure of the page you're trying to scrape? And what kind of server is on the other end? So here's the due diligence we did for the arms list piece. There was no better data source. There's no data source, in fact. Nobody's tracking this nationally. So you actually have to get it from the vendors, from the marketplaces. There's a very predictable URL structure. It's very easy to get data out of their listing system. While the pages themselves sort of make a mockery of bootstrap-driven design, things were pretty consistent. It was pretty easy to pull data out of the pages. Turned out that they had a gleefully libertarian terms of service. The people who run the site wanted nothing to do with the underlying content on the site, disclaimed themselves of all responsibility, and had no prohibition against copying. And so that was an easy one. It was an easy one for me to see, like, this is probably something we can do, and it was an easy one for the lawyer to read through it and say, like, yep, check, check, check. Like, none of this pertains to us. We can scrape this site. And then it turned out that the servers that Arms List was running were fast. They seemed to be robust. When I sniffed around the response headers, there were no weird smells. Everything seemed cool on that front. So let's take a look at that. So this is what I did with curl. Curl -I just shows you the headers for URL. And -W lets curl print out certain variables about, like, what happened. Specifically response times, transfer time, request start time, all that kind of stuff. So this looks pretty good. So, it's a relatively up-to-date version of IIS. They seem to have cache control headers. It just seems like a pretty modern server, so that's cool. And the response time was blisteringly fast. This is just on my internet yesterday morning, just on my cable at home. And this thing came back really fast. So that's good. So, all right, their server's pretty solid. Looks like people on the other end know what they're doing. And then I was, so I did that, and then I was sort of a DOM detective. So it's hard to see, but you can see at the top in the URL bar. Just take my word for it, the URLs are pretty well structured. But then you can see I open up my console and I'm moving my mouse around, and it turns out that the only H1 on the page for a given listing is the title, for sale trade, in this case, Tourist 38 Special. It turned out that the HTML was relatively well formatted. It was pretty easy to identify unique elements on the page that we could extract the data that we're looking for from. And just to go into a little more detail on this page, so we want to pull out, it's, you know, as we're doing this, it's like, well, what do we want to pull out? And, you know, at minimum, what we're looking for is title. Some sort of categorization. So this was listed in handguns. It could have been listed in rifles, ammunition, things of that nature. So we want to, so title, category, price, and then location were kind of key things. And then, of course, the date that the listing had actually been posted. So those are the sorts of things that we were trying to find. Like, how hard is it going to be just to use basic DOM manipulations and get this stuff out of the page? And it was like, okay, well, not too crazy. Here's the terms of service. It's the long terms of service, and it's interesting because they don't bear this terms of service. It's actually a click wrap on the site. So you know, you don't have to fish around. You know exactly what you're working with when dealing with this site, which is good from the standpoint of what we're doing. So scrapers, what are they good for? They're actually pretty good for understanding an information system or an underlying data model. I feel like a lot of what I've learned doing scrapers, especially of government websites, is not so much getting the data, but figuring out how the underlying system works. So, for example, Cook County Jail uses an old flat file database from we're still running on like a mini computer to track inmates, and so they don't have a history of where people stayed when they were in the jail. They just have a field that gets replaced every time somebody moves. And that was something that we were able to sort of see by repeatedly scraping the site. So you learn a little bit about the actual system that you're dealing with. It's good for pressuring institutions to release data. Scrapers are really good political tools if you're an activist or even if you're a journalist, or if you're just somebody who's trying to make change in your company. A lot of times people are like, man, should I release that data? That's scary. You know, the data's dirty. We could get in trouble. Like, you know, there's oftentimes people who have valid reasons to not make their data public, but it's data that should be public. And once you start scraping it and like the world doesn't collapse on them, they'll be a little more interested in maybe opening it up for you. It can really actually open doors and create pressure to sort of get better data. And of course it's good at liberating data into structured formats. But then there's a question about the quality of that data. Occasionally you're going to get good data out of it. With Arms List, we got pretty lucky and we were able to get really good data. But that's not often the case. So oftentimes your experiment will end in you learning a lot and getting something useful, but the actual data you get is going to be maybe a little iffy. And scrapers require resources. So development's the easy part. Testing's the hard part. Like I said, they're all edge cases, right? Like you're scraping 80,000 URLs and on 45,202, a new DOM element pops into the listings that you didn't expect, and now you've lost half your prices, or something like that. So they're all edge cases. You can't predict the future, right? You can do stuff to test and to understand better what you're working with, but you're only ever going to know if it's going to work once you test it with a full corpus of data, and that takes time. And infrastructure is another issue. Scrapers don't cost nothing to run. We're going to talk about how much it cost us. It didn't cost much, a couple dollars. But imagine if you're doing this scrape every single day, those couple dollars add up into, you know, not zero. It actually costs some money. And if you're running your scraper periodically or running it over time, you need to maintain that thing. So that Cook County Jail scraper, as lovely as a project it was, I got tired of paying for the Amazon bill out of pocket, which was $20 a month. And it kept breaking, and I didn't know why, and I didn't have time to fix it, so I just had to mothball it. I mean, it ran for 3 years, so it's not a bad run. But in all events, any questions at this point? Everybody seems very quiet today. Yes?
You mentioned kind of discovered some things about the underlying implementation of the system. Pulled out someone was running IIS earlier. Do they exist? Are they useful? Any kind of standard scrapers for DOM rendering that might be standard for certain kinds of CMS or e-commerce systems?
Yeah, so that's interesting. So, yes, that happens. One place where I saw it was dealing with Cook County, data in Cook County. They had a whole bunch of old ASP servers, and they all basically had the same HTML structure. It was all positional. So like nothing had IDs or classes or anything that identified it. But there was actually a surprising consistency between their warrant lookup system, the inmate locator. There was another one that we were scraping at the same time. And we actually wrote kind of a common parser because you could abstract enough parts of it that maybe, I don't know. I mean, I'm certainly, I imagine similar. Yeah, I don't know. It's a good question. It's case by case in that case, I think. Like you know, you might get lucky if you're trying to scrape 3 different WordPress sites, and lo and behold, they're all using modified versions of the same theme. But you might not. Yeah.
So you mentioned about terms and conditions. So are there certain sites or classifications of sites that are, you know, okay on that? Like I'm guessing like government data is probably public, and you said that like any kind of like public records, like I'm guessing like 10Qs and that kind of stuff would all be.
Yeah, that's a good question too. So there's some states that have tried to copyright government data. I don't know what the status of that is at this point. The EFF's been tracking it. There's a couple of states that are trying to do that. I wouldn't be absolute. It is not a guarantee that government data is in fact legal to scrape. It should be probably most of the time if it is public facing on the internet and provided by the government. That would be my humble opinion about that. But you should always read the terms of service. You should always check with a lawyer. The case law, as far as I understand, is complicated, and there's not a fully comprehensive view of this.
Yeah, and then SEC filings, is that?
You can scrape those.
Okay.
Yeah, you can definitely scrape those.
Case law about scraping in general speech, but if you need government sites from the computers, like then you are potentially, if you get accused of breaking some law of life, because you're breaking is much more serious.
Right.
So I would be very cautious about doing that.
Yeah.
It's very easy to do, and trivial to do. I would be very, very careful to do it.
Yeah.
Get like a DDoS attack against the government or something.
Yeah, so that's one of the things we're going to talk about. I mean, that's what we did. We basically, with the Cook County Jail scraper, we inadvertently participated in what amounted to a DDoS, right? These background check sites and our scraper were all hammering this poor, like, 486 in like, the bowels of some data center underneath a garage in Chicago, and we took it down. And it really was a DDoS because it was multiple parties who were trying to scrape the site. We got lucky, but one of the things we learned from that is we should have just called the sheriff's department. They were happy to have us running the scraper. They wanted the data too. because their system couldn't track where, like, one of the burning questions at Cook County Jail is like, how many times does a person move? And their underlying data system could not track that, and our system could. So their metrics people were like, yeah, keep scraping, woo! This is cool. So but we should have called them first. We should have just found out. And, you know, I mean, for the most part, if it is public government data, like, you should be able to get a hold of it. But that's also why you should FOIA first. That's why you should call first. You should always make sure you can get this data in another way. Cool. So so let's talk a little bit about scraper architecture. We'll talk about data models, tests. Actually, we won't talk about tests today. Sorry, we're not going to have time. And I didn't get a chance to write them. But we'll talk about how you would do it. And I can show you some other tests if you want to talk about tests. Atomic request, parallelization, and the cloud infrastructure we used. And some of you now, if you're big geeks, are probably like, whoa. What about Scrapy? Scrapy is awesome. What about Mechanize? Mechanize is awesome. There's all these tools that help you do exactly what we're talking about. And the reason why, well, there's a couple things. A couple of reasons why I'm not going to show you Scrapy or Mechanize or tools like that. Fundamentally is that we are framework nihilists on my team. We like the fundamentals. We like to build things from simple tools that we understand what they do. We're a little lazy, so if we don't have to learn a new framework, we don't. And hopefully by talking about some of these more underlying issues, you'll understand why Scrapy is built the way it does. Because one thing that I hear from folks, actually after I published a blog post, which I'll add the link to this presentation about, that basically is covering the same material, a data journalist buddy of mine was like, but I still don't understand why I want to encapsulate my data models in classes. He's like, Scrapy makes me do that, and I don't understand it. And so hopefully we can talk a little bit about why, by looking at these kind of lower level choices and why they're important. So let's talk a little bit about the workflow of the scraper that we used. You basically start this process by running a controller script that harvests listing URLs from the armslist.com search listing index. And then it takes that same list of URLs and then launches these scraper scripts, which go out and in parallel scrape and bring back data from the actual listings on armslist.com. So it's a standard model, right? There's a page that you click through to see the details of individual listings. That page has pagination. You can harvest URLs from that and then scrape each individual listing page. The thing that we're going to do here, though, is what I call the Drake principle. So we start with the controller script. It calls the index scraper, which then harvests these URLs, which then in turn calls the listing scraper, which goes out and scrapes the individual listings for weapons for sale. So the Drake principle of programming is that you have to start at the bottom. Wow. Crickets.
Now we're here.
My intern thought it was really funny. We started at the bottom, now we're here. Anyway, we're going to be up at the top eventually. But what we're going to start with, in fact, we'll take a look at the controller script, but then what we're going to start with is actually how we encapsulate the data and work our way up to the full process. So this is the script. It's a little hard to see. It's kind of maybe a little hard to see. But basically, it's a pretty simple controller script. It spits out a list of states, pipes that to the parallel command. We'll talk about that later. But basically what that does is it creates a bunch of scrapers that go out and scrape however many states at a time from the data, and that's just a way to segment the scraper so it runs a little faster. That part's not nearly as optimized as the thing that actually goes out and scrapes the listings. Because there are so many guns being posted on armslist.com at a given moment, even paginating through, sometimes you get duplicate URLs because stuff's being pushed into the top. So if you go to page 2, a listing that was on page 1 is now on page 2. We figured it was a couple thousand an hour, I think, are getting listed. So it's pretty active, which causes some problems. I'll tell you about a gotcha. We realized that there was a better way to do it later, but we had 4 days to do the project, so we did what we could. And then on that last line, this was what we're going to dive into first. We're taking this list of index pages. It's a CSV. It's got some extra detail about the pages. So we're using CSV Kit. Is this handy library that helps you manipulate CSVs. We're cutting just the first column to get a list of URLs, and then we're passing that again into GNU Parallel to scrape the listings, and so it's going to go and it's going to scrape some listings. Whoa. Okay. Is everybody's eyes glazing over? Are you with me? Okay, people are following. That's good. Cool. So let's talk a little bit about the model class that underlies this whole thing. So one of the things that I found is most helpful in writing scrapers is basically to take a chunk of HTML and pass it into a class that hides all the parsing. So that you get an interface out that looks exactly like the data that you want to see. So let's actually just take a look. So the input is HTML or text that we want to parse, that we want to scrape stuff out of. We want a class interface that looks like our output. So if we have date of birth in the underlying data, but what we want is age, we create a data model where you say data model.age, and it calculates the age based on the date of birth. It hides that complexity away so that anything that's dealing with this data model doesn't need to know anything about how screwed up the underlying page was that fed it. And so you can so that way you can hide calculations, hide joining and splitting fields. You can basically hide away all the complexity. So let's take a look at this. This is where I really wish I could get up and kind of jump around. Oh, maybe I can. Does this thing, no. Okay, so if we take a look at the init function for this class, so this encapsulates a single gun listing. This is a gun that's for sale on armslist.com. And you'll see that our initialization method takes one parameter, and that's HTML. So our model doesn't care whether that HTML came from the network, whether it came from an automated test, whether it came from the command line, from standard in. It doesn't care. It just needs HTML. And then you'll see that we use, so there's a little front matter. We're using Beautiful Soup to do the parsing. There's other stuff that works pretty well as well. PyQuery is another library to do this if you're feeling masochistic and or can read German documentation. LXML is good. LXML is actually amazing, but it's just really obtuse. It's not necessarily super familiar to people who aren't used to working with that kind of node level, DOM level kind of interface. So because we want to be, we want our intern to be able to work on it, right? We use things like Beautiful Soup. We want to write code at sort of an 8th grade reading level because we feel like that just helps adoption and it helps our team collaborate more effectively. So we try not to do too many fancy things. So there's a little bit in the init function beyond that, but the key action is let's take a look at line 10 through 12. So we use the property decorator. Anybody know what the property decorator is? Yes, it's getter setter for a Python class. So instead of .title parentheses, a method call on the object, you just say .title, or you say .title equals. So property basically turns a method into what behaves like a property once you access the class interface, or an instance interface, I should say. So the title one's very simple in this case. We get the beautiful soup object and we find the H1 inside of it. Because what we found is that there's only one H1 tag on every listing page, and it is the title that the seller typed in. Tourist 38 for sale, Middle Illinois, whatever. Now, on lines 14 through 22, you'll see a little more complicated one. We have even more complicated ones in this file. But this is a nice one. So sometimes the price starts with a $sign, and sometimes it doesn't. I don't know why. It must be something about typing in how you type in the price. Maybe you're just allowed to type a $sign or not. And so we check to see if it starts with a $sign, jettison the $sign if it does, or just pass through the string. So this is an example of hiding that complexity, right? You want price to be price to be price, to be expressed the same way every time when you're accessing the data, and by encapsulating it as these parsing methods of an instance of this data model, you get this very nice sort of interface. And then you can do fancy things with it because the app property decorator, those properties act truly like properties. So when you have a model instance, you can call dict on it and get a dictionary of all those properties. So you can use all this fancy kind of Python, all this kind of fancy Python metaprogramming stuff, which is maybe a little helpful. So yeah, anybody have questions at this point?
Does this model return back? You might answer this later. If your indexer has 10 URLs and you only get 9 back because something went wrong here, is there any sort of detection that things have gone wrong? Like if you had a price that was money signs 50 with no space, you're not going to get that.
Yeah, so it turned out that we didn't need too much exception handling, but basically we do that one step up. So the model class is supposed. So actually, if something breaks like that, you want it to break, right? You don't want bad data sneaking in. So if this price thing were to break, I'd want an exception to be raised and to stop and to see why the world wasn't as I expected it to be, right? So basically, we step up one level to actually do the actual scraping. So we'll take a look at that right now. So let's take a look at the listing scraper file, which takes this data model and calls it. And there's some kind of. So this is what makes the magic happen, basically. So in addition to having this data model where we can encapsulate a listing, we have a scraper script, a very simple thing. I would have loved to show you the whole thing because it's only a few more lines than this, but it would be hard to read otherwise. And the scrape listing function takes a URL, it creates a listing object out of that URL, and then just spits out basically a CSV output to the console. And one thing that we could have done, and very well may have been smart, would have been to wrap that bit from line 15 to line 22 in a try except to capture any errors if we ran into any errors and maybe log those. It turned out that this was such a simple scraping job in a lot of ways that we didn't have to, but we got lucky in some sense and might have wanted to do that. But I would put that at that level, not at the level of your model. Your model should break when the data isn't what you expect. That's good, right? because now you know that there's going to be that you have a new edge case to contend with. And we ran into some kind of funny edge cases. Like every state, you can get listings by state. Every state uses the standard abbreviation except for New Jersey and South Florida, which is not a state. So if you look in this code, you'll see when it returns state, there's an exception that says if it's South Florida, return Florida. For some reason, there's so many guns, in fact, being sold in Florida, I guess, that Arms List has decided to consider it 2 different states. And then there's the index scraper, which harvests the index URLs. We're going to skip that one because it's actually basically exactly what I just described. But you can take a look at the code. We can talk about it later. And then last but not least, let's talk again about this controller script and specifically about GNU Parallel because this is really a handy tool. So anybody done multiprocessing parallelization in Python? I've seen some hands. Is it the most fun thing? No, it's not fun at all. You can do it and it's pretty cool, but again, I feel like I want my Python code to be something that like an intern can jump into and just be immediately productive. And if I've got like joblib calls all over the place and like trying to parallelize like loops and asynchronous things are happening, like forget about it. Like that's impossible to read. So let's put that parallelization actually up 1 level. Like let's put this at the level of actually calling of actually scraping a single listing and parallelize that. And let me just go back for a second. So this is really crucial too because I can just run, if I want to test this thing, I can run scrape listing.py and get the output of a single URL. So it's very easy for me to test this scraper in this way. I can show you, but I think we're going to run out of time. Yeah, so GNU Parallel is really handy. GNU Parallel basically says, take some input, like cat a file, a list of URLs, and then you call the command that you're going to call with parallel in front, and then curly braces as the argument substitution, and all of a sudden you have parallel processing. It automatically detects how many cores your system has. You can overload it, you can underload it, whatever you want to do. It's a really handy tool. It's mainly used by academics, and so that's why the world doesn't know more about it.
If one of the scripts, one of the instances of that fails, does all the battle jobs?
It doesn't. It just keeps running. Yeah, it just keeps running. Which could actually have its disadvantages if you saw something break and but it also responds to standard like console signals. Control-C will stop it. You don't have weird processes hanging around. It's really cool. So that's basically what's happening in line 11. We're getting a list of URLs and passing that to parallel, which is calling scrapelisting.py, and then the curly braces represent each URL that's getting passed in. So imagine the CSV cut is basically just a list of URLs. That's all it is, right? And it's being piped to parallel, which is then substituting each URL for scrapelisting.py, and parallel is figuring out how to optimally parallelize this process on your computer. And we'll talk a little bit about the infrastructure because it's helpful to know just how handy it is to do this parallelization. We use Amazon EC3. I think cloud services in general are a very good way to go when you're doing scraping like this. And we fired up what is actually a fairly expensive server, a C3 8X large that's a 16-core machine. If I recall correctly, it's 16 or 32. It's big. It's quote-unquote compute optimized. We didn't have one specific bottleneck. We weren't like blowing up memory. We weren't blowing up processor. But the thing that was most intensive was processor. So we got a compute optimized instance rather than say like a storage optimized instance. In all events, we were able to scrape about 80,000 URLs in about 16 minutes. So not bad. And that included the less than optimal harvester of URLs, so it was pretty fast. But it's always important to remember not to accidentally create a denial of service attack. I should note that 16-minute scrape meant about 50 cents a scrape. But remember to turn off your EC2 instance when you're done with it. You don't have to terminate it. You can keep it ready to like fire up again, but you're charged for every minute that it's on. So you can save a lot of money if you like fire this thing up, spin it up, run it for as long as you need to run it, 16 minutes. But as you can imagine, like 50 cents every 15 minutes actually isn't cheap if you accidentally run this thing 24/7.
Obviously, you did this one. Even if you have permission, do you put any kind of rate throttling or detection in there to change your scraping rate?
So there's two things that you should do. You should put a header on your request that identifies yourself. It's the ethical thing to do. It's if you're a journalist, you absolutely should do it because we're supposed to identify ourselves, right? If I'm interviewing a subject, I can't lie about who I am. And we feel like that principle should apply to scrapers that we're writing as well as interviews that we're doing of sources, right? And then, yeah, so let me go to the next slide because it speaks to exactly what you're talking about. You should proceed with care in terms of slamming another server. It's hard to know what level of traffic will knock out a server. You should increase your number of parallel requests incrementally. If you notice any kind of slowdown or hiccup, back off. Like chill. It's better to throttle and put in some like 1 second waits or half-second waits, or send less concurrent requests, and accept that you're just going to have to be patient in getting your data than any other alternative, right? You don't want to get sued. You don't want to get in trouble. You want to be a good citizen. So you want to be careful about that. But the tricky thing is, unless you actually call the folks, and sometimes you can't. We did try to call Arms List, but they didn't call us back. You don't know. You honestly don't know what's going to take them out. But we did a little background, and what a world we live in. A little background research. So what a world we live in. We put the late capitalist technical infrastructure monopoly to work on our behalf. So it turned out that we use Amazon EC2. It turns out that Arms List uses Amazon EC2. And so we were actually able to put our scraper in the same data center that they were in, and get lightning fast network response times. And we incrementally increased the number of parallel scrapes. We realized that we could use a very big server and cause them no trouble. And so we use something quite optimized. But if it wouldn't have been the case, we would have just slowed down. It didn't matter that much.
Determine if they were using the server and where it was.
Oh yeah, so we use the MaxMind Geo IP. There's a couple IP tools that will let you do this. MaxMind is like an IP geolocation service. Really helpful. It's how we figure out that you live in Nebraska, so we can at NPR, so that we can show you how much your local school district spends per pupil, things like that. But they have a little demo site. You can put in some URLs or put in some IPs and find out where they are in the world. We did that anyway because we were like, well, let's pick a data center. If this is on the West Coast, let's pick a data center on the West Coast. If it's in Asia, let's pick the data center in Singapore, right? So we just wanted to know where we wanted to put our server, and when we did the MaxMind Geo IP lookup, we were like, oh. We can put it in the same data center. So that was a little sneaky bit of code, or a little sneaky bit of detective work in our case. In all events, we've only got a couple minutes. So just to finish up, we published the CSV with the story. We documented the code, and there's actually a couple to-dos on our end. We want to write tests. We should have written tests, but we only had 4 days. But at least through the model interface we could just stick some HTML into the model class and like see if it works the way we expect. We realized that we could have used incremental IDs. It's just a counter on armslist.com. Their IDs are just a counter, and so there was probably some optimization we could have done around using that URL pattern to our advantage. And then there was just other analysis we wanted to do in our story that we didn't get to. All right, so we only have 5 minutes, I think. Does anybody have any quick questions?
I'm gonna cut that off because there's supposed to be a break in between.
Oh, I didn't know there was a break in between. I'm sorry.
Okay.
Okay, come talk to me. Thank you.